All right, I'm going to do this example. This is a pretty simple example using implicit differentiation, just so we get the idea of how this works. So when we take the derivative of x times y, we can see there's a product here. So we got to use the product rule. So the derivative of this is the first times the derivative of the second. Well, think about earlier when we have the derivative of y equals x cubed or whatever. We got so used to it, we forgot what we're doing. We just said y prime equals 3x squared. But what we're doing to get that is we're really taking the derivative with respect to x of both sides. Right? So the derivative of y with respect to x is dy dx. The derivative of 3x squared with respect to x is 3x to the 2. Technically, we are using the chain rule. Then we multiplied by the derivative of x with respect to x. But the derivative of x with respect to x is just 1. So we don't write that 1 when we're taking a function in terms of x with respect to x. But when we take the derivative of y, we need to write the derivative of y, dy dx. So back to this. The derivative, the first times the derivative of the second. Well, the derivative of y with respect to x is dy dx. Plus the second function y, what is the derivative of x with respect to x? It's just 1, right? Technically, it's 1 times the derivative of x with respect to x, right? The chain rule, but this is just 1. So when we're taking derivatives of functions that only have x in it, and we're taking the derivative with respect to x, we don't usually tack that on, but it is there. So the derivative of this function we could write as xy prime plus y. Yeah. So that's the idea. You got to remember when you're taking the derivative of a function that has a y in it, well, the derivative of that y, we're going to end up with a y prime in there, or a dy dx. So let's find the derivative of this. Find dy dx. So what we're really doing is we're taking the derivative with respect to x of both sides. So the derivative of this. First, let me just rewrite this. We have x squared, y squared. Let's write this as x plus y to the 1/2 plus 6 equals the sine of y. Okay, so here again, like the example I just did, here we got to use the product rule. So it's the first function times the derivative of y squared. The derivative of y squared is 2y to the 1 times the derivative of y, but the derivative of y is y prime. Yeah, so that's the first times the derivative of the second. Then we have the second function, y squared, times the derivative of x squared. But the derivative of x squared with respect to x is just 2x. Yeah, so that's the derivative of this. What's the derivative of this? Well, again, we're really using the chain rule here. So the derivative of u to the n is 1/2 u to the negative 1/2. But then the chain rule says we got to multiply by the derivative of what's inside the parentheses. The derivative of x with respect to x is 1. The derivative of y with respect to x is the derivative of y with respect to x. It's y prime. So that's the derivative of this term. The derivative of any constant is 0. The derivative of sine y is cosine y. But remember, our formula is the derivative of sine u is cosine u times the derivative of u. And the derivative of sine y is cosine y times the derivative of y, but the derivative of y is y prime. Yeah? So now what we got to do is we've got to isolate y prime, because the actual directions, I didn't write it down, but our directions is find y prime or dy dx. So let me just simplify a little bit. So what do we get here? 2x squared y prime plus 2xy squared Let me distribute this. This quantity times 1 is just this quantity, 1/2 x plus y to the negative 1/2 plus this times y prime. So we have 1/2 x plus y to the negative 1/2 times y prime, and that's equal to cosine y times y prime. Now to isolate y prime, just like we did in algebra, we need the y primes on one side and terms without a y prime on the other. So y prime terms I'm going to collect on the left side. 2x squared y, this has a y prime, so I'm going to leave it. Now I'm not canceling here, I'm just crossing it out so that I know I took care of that term. This does not have a y prime in it, so we move it to the other side. But remember, whenever you move something to the other side, it just changes sign. This becomes negative 2xy squared when we move it over. This does not have a y prime in it, so that becomes negative 1/2 x plus y to the negative 1/2. Let me cross those out because they're taken care of. This has a y prime in it, so we leave it on the left side. And this does not have, this has a y prime in it, so we move it over here to the left side. But whenever we move things from left to right, it just becomes the opposite sign. So this is just going to become minus cosine y, y prime. So we have minus cosine y times y prime. Why did we do that? Well, now there's a y prime in each term we can factor out. So we get y prime times 2x squared y plus 1/2 x plus y to the negative 1/2 minus the cosine of y, because I factored out the y prime. And on this side we have minus 2xy squared minus 1/2 x plus y to the negative 1/2. And now there's just one step left. We divide both sides by this quantity right here, 2x squared y plus 1/2 x plus y to the negative 1/2 minus cosine. And we divide this side by the same thing, yeah? 2x squared y plus 1/2 x plus y to the negative 1/2 minus the cosine of y. Of course, any quantity over itself is 1. That's why we divided by the coefficient of y prime. So they cancel, they're really 1. So this is y prime. Y prime is this quantity right here. So this is our answer. This is y prime. Let me erase this because this is y prime here. So let me just write this as y prime. So this is our answer. Of course, you could simplify this a little bit if you wanted, but that answer suffices.